Hey everybody, this is Larry, this is me going cute. We have the weekly contest 469, number of ZigZag arrays 1. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this one. This is a very hard problem even by itself, but what made this harder is that the code is silly. And we'll go over the Leetcode silly part later. I end up taking about, 44 minutes plus 2 wrong answers. But if you watch the live portion, I got about 95% of the code in 10 minutes. It is just that, and you can maybe see a little bit of spoiler. I just got time limited because Python and Leetcode doesn't mix for this problem. There are ways to optimize it such that it works, but it is just unpredictable. And yeah, it is what it is. But okay, but first of all, let's actually go over the problem and my intended solution, right? The first thing to say is, and I say this in the most generous way possible, I say this in the most generous way possible because, and what I mean by that is because I made this assumption during the contest and I was wrong because Leetcode is sketch. I'm still a little bit toasty about it. But yeah, but you see that this is 2000. So okay, so I'm like 2000 square works. L and R is less than 2000. So like 2000 square should work. Of course, it would also work a lot faster and if this is 1000 and also fundamentally does not change the problem. So it is another case of Leetcode just being a little silly, a little insensitive, and a lot of people getting wrong answers for no reason. What a waste of a contest as a result. And it's one of those things where like Leetcode thinks that, ratings are worthwhile, but it's garbage in, garbage out. When you have garbage contests, your rating is garbage value-wise, right? Like, how do people take your rating seriously if you let these things keep going? But in any case, yeah, the problem itself is fine. The constraints is silly. But the key thing to note is that, honestly, it is just, once you notice this, and you may start trying to do dynamic programming things, right? And try to write it as brute as possible. And I will do that here. Let me rewrite I clicked on submit by accident. Okay, it's going to time out. It's fine, right? But the idea here is that, let's just say you have a memorization function. I'm not going to go over dynamic programming in this problem just because there's already too much to go about. It is a good problem. It's an interesting problem. I wish it stayed that way instead of, give me back my, this is my code. I wish it stayed that way instead of becoming this crap show that it was. But in any case, yeah, so let's just say we have a function, right? A function that counts. All we have then is the current number, right? We have the number of numbers left, and then whether the last two, because we only care about the last 3 digits or 3 numbers. Well, if you already have 2 numbers, then the third number is the one that, whether it continues to increasing or decreasing has to be the opposite, right? So maybe you have a Boolean increasing, right? So then now, current is the current number, right? Left, the number of numbers left, right? Increasing is the last 2 numbers. Are they increasing or decreasing, right? And that's it, right? And of course you would memorize it or whatever. And if left is the base case, if left is equal to 0, we return 1 because that means that all the conditions always were satisfied and we have no numbers we need to fill. Otherwise, then now if it is increasing, let's make this binary for now, increasing. If it's increasing, then we have total is equal to 0, just total things counted up, right? We want to write for, we just try every number that's bigger, right? So for I, in range from current plus 1 going all the way to let's just say R, right? Because that's the problem. Or maybe is it R plus 1 to be inclusive? I mean, this isn't real code, so I mean, I am writing it like it's real code, but it's more pseudo code just to get you the idea of what it would look like, right? because this is not, I mean, this is correct, it is not fast enough. So then this is just going to be I, left minus 1, and then now because it's increasing, it is not going to be decreasing, so maybe just false, right? And then now if it's decreasing, then actually I messed up, right? So sorry, I messed up. I lied. It's the other way, right? So if it's not increasing, so if it is decreasing, then now we can get the next number can be increasing. So we do from current plus 1 up, right? So my apologies. Otherwise, then the previous one was increasing, so now we want to decrease. So then now we want to do current minus 1 all the way down to 0 and increment of -1, right? We're counting down is what I'm saying. So yeah, so again, this is just, you know, same thing except now this is true. This thing, right? And then that's it. I mean, you have to remember the mod or whatever, but that's fine, right? So that is the core essence of the code. What is the complexity here, right? Well, current is going to go from 0 to n, yeah. Oh no, the other way. Sorry, L to R, which is up to 2000. Left can go from 0 to n, also up to 2000, and then increasing is true false, right? So true false, so 2, right? So this is about you know, 8 million. Not great, apparently too slow in either case, but you know, within the concept of fast enough. Let's just pretend this is fast enough with about 8 million inputs. But the problem is that, okay, we have 8 million inputs. But the problem is that each input takes O of n. Is this n? No, technically O of R or L minus R or R minus L time, which is another 2000. And of course, 8 million times 2000 is too slow. So that's why this is too slow, right? Okay. So then what can we do here to make it a little bit faster? The thing that I think there are a lot of ways to think about this, but the way that I think about it is visualization. So let me bring up the drawing board really quickly. Hang on. After these messages, be right back. Where's my pen? Okay. Yeah, the idea behind these kind of DP, and sometimes I do like to write it out for that reason, is that, yeah, so if you have a matrix, right, that we're thinking about, what's this matrix? This is, let's just say current and left. Increasing, decreasing, let's ignore that for now, right? Because I cannot draw three-dimensional that easily. But let's just say, you know, yeah, let's just say one of the index, let's just say this way is going left, numbers left, right? Numbers left, and then this way is the current number, right? Yeah. I cannot write diagonally easily. It's not just a matter of... Actually, maybe it is. Hang on. Alright. I tried rotating the board, but anyway, you get my point, right? This current is going to that one. And then now, let's just say we have a cell, right? So this cell represents what we call goal of... I mean, I could write it out, but yeah, maybe I should change the colors though. Hang on. Goal of, let's just say C and L, right? For current and left. Just so I don't have to write it all out, right? And then what is this? As we kind of look at the formula real quick, and by formula I meant our formulation, let's just pretend that the increase is increasing. So then now, what does that look like? That means that we're going to look at current plus 1, left minus 1, current plus 2, left minus 1, right? So what does that look like on the visualization? Let me bring it back. Hang on. So left minus 1, okay. Let's just put, I don't know if I drew the thing in the right one, but let's just say this is goal of C plus 1, L minus 1. So that's this cell, right? And then you also want to do, goal of C plus 2, L minus 1. and then dot 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 dot, right? All the way through, all the way to R, and this is the R constraint, right? And then now if you have this visualization of all these cells, then here we're trying to get literally the sum of all these cells. And the way to get that is by, well, prefix sum, right? That means that if we're doing them in order, for example, I mean, that I'm going over the, in this way, we're looking at cell. So then now we can, in a visualization kind of way, because we're doing this by L, which is how many numbers we have left, we can just say we do, let me change the colors real quick, actually. Let's just say we do them one left level at a time. So then we do all these, then we now can prefix sum, this chunk. So then now the blue cells would be equal to the sum of all the red cells underneath it, right? So something like that. I know my drawing might not be the best. My apologies. I hope it's still better than nothing. But I just want you to get a visualization of what is going on, because the next steps are going to be a little bit faster, assuming that you understand the visualization, right? The visualization is that now that we have all this, so then now we have prefix sum, and yeah, okay. So then now what do we do, right? So then now we have here. What we want instead of having this loop is that we just want this loop to have a prefix sum from of left minus 1, but from current plus 1 all the way to R. And that's basically what I have here. So I'm going to just copy and paste on my actual code. Actually, maybe that's fine. Maybe I'll just go straight to the actual code. All right. So this is actual code, and this is what I did, right? Here, initially, I thought increasing doesn't need to be, because I set it to 1 and -1 and 0. I don't know if it's not necessary, but I did it that way. But yeah, but you can see that this is, I call it P up for prefix sum up and prefix sum down, right? If it is not increasing, then you do go up. If it's not decreasing, then you go down. And the way to do this top down is just by a prefix sum kind of memorization, right? It calls the function for, so given current left and going up, which is increasing, we just call the function there plus the next number on the list. So in this way, this is how you get the prefix sum from order sum. This may look a little bit confusing because this is still a loop, but it is not, because then now in future calls, this is O of 1. So you only have to do this once, and you could analyze this like you analyze every other dynamic programming thing, right? Let me actually go back and analyze this now. Let's just assume now that we're able to fetch, because we already calculated this, O of 1, and this is O of 1, right? So then now, same thing here, which is the same thing that we had here. Right, the same thing that we have here, except for now, each input now takes O of 1 time, O of 1 time, so then is not too slow, right? That's basically the idea behind what we want to do. And I put the not in quotes because 8 million is still a lot, and apparently Leetcode is silly and it made it too slow. So that's basically the thing I want to point out. And but we'll analyze this real quick first, right? So this is the same idea. Current L to R up to 2000, right? Left, same thing, 0 to N, also up to 2000. Each input, we have 4 million inputs, right? I'll just write 4 mil inputs. Each input takes O of 1 time, 2 calls. So that's it. And you can imagine it's the same for P down. And of course, not all the numbers are possible, but this is like an upper bound, right? So it's going to be R times N, or 4 million. And in theory, that should be fast enough, or you would hope so, because I don't know. But apparently, Leetcode is silly, and it is not. There are a couple of things you can do. I'm not going to go over it too deeply. What I end up doing is that I converted to Java. It was fast. Oh, wait. First, I did convert it to top down. Yeah. I'm not gonna go with this really detailed. You can watch the live portion a little bit to maybe get an idea. But oh, let me submit this. And I know that this doesn't work, but I wanted to get it on record before my comments. So if I need to come back to it. But yeah, and this is kind of the same idea except for why is my okay? I was looking at my screen. I was wondering why I was not updating, and I don't know if it's my computer's being silly. But in either case, that's fine, right? But yeah, but this is the DP. You could watch how I converted one by one, and I actually struggled a lot because of off by one logic. But this is basically the equivalent, and I'm just showing to you. I'm not going to explain it too detailed, just because this is, yeah. But the reason why I do want to bring up is that this does have has a strict. I mean, you could, if you just remove or ignore for now the increasing, decreasing. Oh no, that's not it. The increasing, decreasing thing. This is basically what we said, right? Because now we have this thing as you go to this thing, but this thing it's a prefix sum, and you could see the prefix sum construction much more cleanly, right? Of going up and down, right? Yeah. And then basically this still times out because Leetcode hates Larry, and I just converted to Java and it was fine. But as a result, I lost about 34 minutes plus 2 penalties. So yeah, so not so Gucci on this problem. But yeah, hopefully, yeah, I'm gonna show you the code. Let me make this slightly smaller. But this is the code if you want to understand it. I'm not gonna show you the Java, it's exactly the same anyway, and you know. But yeah, and the complexity maybe is a little bit easier to see. Oh, one thing that I did change is that noting that for this problem, you know, you have L to R, but L to R is the same as going from 0 to R minus L, maybe plus 1, right? Inclusive, right? So as a result, that's basically what I did. I converted the domain so that we can change this. So it just goes from 0 to R. That's basically what inclusive, and that's what this problem is all about. And yeah, and I was struggling with off by ones for a little bit until I tighten it up. Very silly, but yeah, and I think this one is not even necessary. But that's basically it. Yeah, let me know what you think. Oh yeah, the complexity. As a result, the complexity is much cleaner to see, right? This is just 3 times R, 3 because I have increasing, decreasing, and both. You don't need the both apparently, but that's what I had. But also just to be clear, even when you take away the both part, it's still too slow because Leetcode. But yeah, this part you can see that is n times r times r times r, or not times r 3 times, but it's just n times r times 3. So yeah, that's it. That's the complexity, and that's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you can watch me solve a live in contest now. Oof. Oh, 2 hard problems today, and they're related. All right, we'll see. How's the ranking going? How many cheaters am I behind? Okay, good. Well, people are already done, so man, I got some work to do. All right, let's go. Can anyone read the poem yet? I like my things up with capital. So constraint is 2. Is the only difference? Only difference is n. All right. Mod. I see. So DP is probably this one, right? For Q3. So 4 and 5. Yeah, DP. Okay. Yeah, 2000. So okay, so that should be good. Maybe. Yeah, no, it should be good. Not great, but maybe fast enough. If it's too slow, then it's Leetcode's fault. I can't believe this is my thing again. So if it's increasing, then okay. So that means that okay, I think that's it. Maybe. How do I write this? How do I write this really? Okay, I mean, I guess, yeah, fine. Okay, yeah. No, is that fine? I'm wrong. No, this is too slow. Okay, so I have to think about it a little bit. Because there is another index of left, that's why it's not fine. No, at least I got the first two fast enough. And without any silly mistakes. But even though and then Q4 is, oh, this is 75 though, so there's actually something to abuse there, but it makes it a different problem though, so I don't know that I can even solve the hard one, or if I solve the other one, I could solve this one. So it's not DP, at least not this way. Oh, actually, I guess you can. If you do a prefix something. But it's not going to be fast enough. I don't know. I see, yeah. Okay, yeah, I guess so. I mean, we'll have to try. Just return go. So if we're going increasing, then that means that we are going, okay, so it's going to be the same direction. So then now we want current left increasing plus 1 plus 1 left. Right. Same thing for down, right? Okay, so then now, yeah. If left is equal to 0, then yay, we're good. Otherwise, then now we want to say try all the numbers that are bigger, right? So we have no, P up. Okay, so if increasing is not equal to 1, then we do this. The other one now. Alright, I think that's roughly right. Maybe not. Oh, right. Is this not increasing? Oh, it is, but I spelled it wrong. 1 and 3. That's not right at all. That's a little bit sad. How do I even debug this? 1 and 3. Why do I have 1? We start at the number 4. Why do I only have 1? Am I miscounting? Pop left. We go up. So we start at 4, we're 5, right? I guess this is the only way to really start. No, I just wanted to make it smaller. And I don't know how to use this, but okay. 5. Why do we start at 5? Don't we have a 4? We have a 4. Oh, I guess this is... Okay, so we start off at 4, we have 2 numbers left, we go to 5 with 1 number left. It's increasing, so then we want... Oh, I messed this up. No, that's right. We go down. So it's 1, so then we go down, so then we go to 4. Okay, so it goes to 501. Why? That shouldn't be. Oh no, it goes to 401. That's 1, so that's 2. Oh, because I'm just dumb. There should be an add. That is the dumbest way to needing to debug. I actually was thinking about that when I was writing it, but I just forgot. Okay, Larry. Alright, how do I do a test cases? This new UI is weird. So we have 2000. From 1 to 2000 should be the max case, right? Memory limit exceeded. Why? Because Leetcode and Python, that's why. Right? Current is 2000. I mean, it's... I mean, it's a lot, but also not a lot. Do I have to write this bottoms up? Maybe I should win this bottoms up. I mean, this is definitely not going to pass if this doesn't pass this, but this is so dumb. This is why I don't do Leetcode anymore. But how do I mean, this is just Leetcode being dumb. It's not even that much memory. I do clear it, but apparently it's not good enough. Yeah, okay. Alright, let's just convert it to, I'm trying to think whether I should convert it to bottoms up or to Java. Bottoms up is a little tough though, because these are like not these are not like full per se. Once again, screwed by Leetcode. How do I write this bottoms up? Oh yeah, I guess. Oh, actually, I guess it doesn't have to be sparse. If L and R doesn't matter, right? So then we can just write and then we just start from 0, right? Is that the same? Hopefully. Double check. I forgot to remove the TLR case. So now I can do bottoms up easier. Okay, well that's not true. Did I miss by 1? Am I missing by 1? From 0 to R minus 1. I think this is this now maybe, but this only makes it smaller. So, what am I doing wrong? Do I still have L anywhere? No. Why? Tell me. I don't want to debug. Maybe I have to. Oh. Maybe that? Am I messing this up? No, that's not right. Shouldn't that be right? Why is that not right? Alright, let's see. Is it this? Did I mess that up? Okay, I just messed that up. Okay, that's fine. So I thought if I did a -1 here would fix it, but I guess it's just interactions between these things. Okay, so then now we can do a DP, right? How do I write this? What I want it to be? DP of left increasing, right? So then inside and then left is going to be n plus 1 maybe. Let's just do n plus 1 just in case. And then current. Now we want to swap these for performance reasons, yeah, which is also pretty silly, but okay, fine. So then now increasing, that's going to be R plus 1 or R plus 2 maybe. Let's do R plus 2. And then range is going to be just say 3, right? Okay. Okay, what's my base case? Left is equal to 0, so increasing doesn't matter and current doesn't matter. Just left is equal to 0, so current is going to be this. Right, did I do it right? Yeah, okay, hopefully. Okay. And then now we have, okay, 4. Current is going to go up to 4. Is it +1? No, I mean maybe, but doesn't matter. Maybe, I don't know. No, it should never be n the way we set it up. Maybe, I don't know. Okay, if left is equal to 1, then okay, then now do 0 to 0. Okay, so we add 1, so this is going to be p up of current +1, left -1. I hate that they make me, I mean, this is already, like, I had it when it was 60 people got accepted, and now like 50 people leapfrog me and I'm not even done yet. That's why I hate Leetcode, and that's why I don't do it anymore. But you know, it is what it is, right? Nope. Remember you changed it. Okay, fine. Okay, so then we have this. But then now I have to, I don't know how, I mean, I do know how, but one of current is I, okay, so something like this, I think, for that part. But now we have to do this part, which is not quite, what is current and left, right? So do I do this first? This is a mess. Okay, actually I should write this down. What does this mean? Okay, this is, we don't, do I need this? This is the prefix sum of the up of current +1. So this has to be, if we do current in this order, then it doesn't make sense, right? No, I mean, does it? I think left has to be in the loop earlier than, because left depends on that. Okay, that's fine. And then now, how do I do the prefix part? I'm just confusing myself. Okay, so No, Larry, you're dumb. This is -1. You don't have to do the ordering. Okay. Then here we can say pre up. So left is the same, so it's just current, right? So then now, wait, we just I don't know if this is right, but okay. So then now we want left -1 and then all of current. So this is left -1 and all of the current I should save the cache version actually somewhere. I'm dumb. Okay. Something like that. I'm also worried about off-by-ones as well. No, then you're skipping the. I mean, it's actually this way. And now we don't have to left and it's just okay, right? Kind of. Okay, but this is not quite right because this is the previous number plus dp of. What's dp again? Increasing, so it's 1 current left -1, right? Something like that. Oops. Oh, no, it's 1, so it's 2. Yeah, okay, something like that. I really should have saved it though. Okay, well, I hate Leetcode. I hate Leetcode because memory. Okay, well, actually, even before I debug this, let me try. Because if this one's a memory on this, then it doesn't matter if I optimize it, right, or correct it. Okay, so once fast enough-ish. Isn't there a thing where it tells me the time? 2.5 seconds. I don't think I could do better than that anyway. So, okay, so then we have a chance to debug this. So let's debug it. Let's get rid of this real quick. Okay, so it's returning 0, which is not what we want. That's for sure. And am I saying this wrong? Left. This is kind of right, but of getting left -1, so left has to start at 0. If left that is 0, you go to 1. So we did set up the left is equal to 0. Maybe we have to set, or no, then it's just n+1. Okay, I think that's why. Maybe. Okay, so I think we had this before because of R, right? R+1 maybe. So maybe something like, I don't know. Right, maybe not, but I mean, it's something like that though. Double check. All right, maybe too much. One of these is wrong, but I don't know which one. It's fine. Am I confident? current can go from 0 to R plus 1. Is that even right? I don't know. All right. Like, am I just like lucky? Like, if I change this and this, does it work? Nope. So, okay. So maybe that is just what it is. Okay. Blah, blah. So it has to be this? Precisely. Nope. The other way. Alright, let's just, I mean, it's so stupid because I got this like so long ago and now I'm like really behind, right? I don't know if this is right, but hopefully. How long did it take? How come it doesn't tell me the time it takes? 3 seconds? I don't know. This is not great, but I'm gonna YOLO submit at this point. If I get a wrong answer, I'll be really sad too because I don't know how many people got killed for so far. It's gonna time out, isn't it? Wrong answer is even worse, actually. I should. I wish I had my old code. Actually, do I have my old code? Oh, I did have it. I just want to see whether this works on the yeah, I mean, we already got this wrong, so okay. That's really sad that my Emacs doesn't format it correctly. Are you serious? Okay. Oh, I just have to copy again, maybe. Right. So I'm trying to see whether this is just like, I mean, I'm not surprised only because I think my indexing is wrong, possibly. But I shouldn't need to, right? Yeah, so my good code is good. So it's just about this thing, probably. Oh. Honestly, yeah, I'm messing too much with the indexing. Like I have 174, but I don't. Okay. I mean, this feels very wrong anyway. It should be this maybe. Nope. I think about it, Larry. Also, this is a little bit awkward, I think. Maybe it's this. Maybe I'm off by one somewhere. So we saw. And then now this is this. I'm just not thinking. I'm just like trying to plug things in and trying to work. But just very annoyed, to be honest. So then so up or down. Even though my I'm so annoyed. I think slow it down, Larry. Plus. Okay, right. So now you have from 0 to R plus 1. That's from 0 to R, okay. And then now we want to go from R to 0. I don't know why this would be the case. And then now P down has to reverse. Alright, we're all not good. Why is that? Right. I mean, I just want to see something not 0. And I got this like half an hour ago. This is the most frustrating part, is that the idea is right, but they make you implement it in a very specific way. So it's not about, I'm just pissed. Oh, Dumbo. I did actually know that part. But I didn't know to remember to remove that part, but I forgot. Okay. I think this is right, so this should be... no, this is way wrong. Right. This is actually very weird. How is this worse? Oh, no, this is right. But this shouldn't change that much, right? Like, this should just keep going. But also, yeah. Why? How is this even worse than before? This is just prefix sum. Why am I so bad at this? I mean, this should be right. Is the indexing wrong? The opposite in, I don't know if the all was to make sense, but because they should match this. I don't know why I would. I think this makes more sense, but the numbers are not right. Well, is it current -1? Did I confuse the two? Down would be, yeah, why would I do, no, then this is not reverse. P up is the reverse one, right? Oh man, I'm dumb. Okay. Alright, this looks slightly better, but I'm still off by 1 somewhere. This is where this is supposed to be a 2 and it solves it. Nope. 2 and solves it. Because this makes sense with that one, but nope. This should run out of bounds, yep. Still off by 1 somewhere. Why wouldn't you work? I just want you to work. Maybe this. If I'm not doing the base case correctly. Oh, I mean, this changed something. So this is probably more right, really. No, why? Why would all +1 be the right thing to do? 0 to, man. This is annoying. Should only go from all should not be included. All should not be included. All should not be included. Right? Maybe I should have done that to begin with. Okay. All should not be included. Then why is this still wrong then? Why? Oh man, I am just not having a good day, am I? Is it just zeros? Like, do I have to do like... Maybe that's why. Maybe. Well, that's too much then. But there should be zero. Should be no way to be z. Okay, well, if increasing is equal to 1 and left is not equal to n, then we continue. Right. Ah. How does this even get? No, I guess this isn't needed because it only gets the last one. But how am I getting 120? I'm like missing one number. I'm off by one. Now I'm like YOLO trying random stuff. Why? How? Okay, so okay, so it doesn't go out of bounds. How am I doing things wrong? This should be out of bounds. Nope. How is this not out of bounds? I'm still doing it wrong. Man, I am so disgruntled on a problem that I already solved an hour ago. But I should also know how to do this. Like, this is not impossible. What was my original code? Let me see my original code. Increasing current left, okay. Current plus 1. But no. That was it because of the prefix sum. Alright, YOLO submit. How many people got Q4? I'm so far behind because I spent so much time on this stupid problem. And I should have already gotten it. I don't even know if this AC is. That would be funny if this just times out and I spent all this time debugging for nothing. And I don't even know how, I mean, this is fast enough. Maybe not, apparently. I guess I should have just converted to Java. I mean, there is a memory optimization idea on left, I guess. Right? Okay, so let's do that first, even though that's messed up. Actually, alright, let's just do it. which one is the left one again? The last one, so it's the inner one. Never doing Leetcode again, by the way. The contest, not live. It's just dumb for me to keep, you know. And then here, that's left, right? Oh, what? DPIJ is oh, it's not IJ. Why is that not? Did I have an extra thing? I do have an extra thing. Increasing current. Why? Oh, that's because I. No, this is what. Oh. No, this is why. Oh, because I also have to do this here. Alright, now it's just wow. Is it faster though? Not really. Alright, I'm just going to use the Java version. Is this right? This is the different answer from that I had before in the Python version, right? Is this the right version? No, this is the... Where's my... 5.9 something. Okay, so maybe that is right. And is this fast? Pretty fast. I hate Leetcode. Thanks for watching, everybody. Hit the like button, hit subscribe, and join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.